All right, welcome back, guys. So now we're going to go over kind of some of the quicker problems that we're able to solve from the 3-1 to 3-6 multiple choice. You might have already watched the one with the harder problems. These are going to kind of be a little bit faster. And the trick with these AP problems is that sometimes they look like they're hard, but they actually turn out to be like a really fast problem if you know what you're doing. So I heard one person say to me once, to do well on the AP calculus test, you just have to know calculus. There are no excuses, no shortcuts. You just got to know it. And if you know it, then some of these problems are really fast and easy. So let's take a look. Chain rule, product rule, quotient rule, derivative, limit definition of derivative is going to sneak in, especially on this video, and trig derivatives as well. So remember our limit definition of derivative, h approaches 0, f of x plus h minus f of x divided by h, or limit as x approaches a, f of x minus f of a over x minus a. Either one. Let's take a look. And right off the bat, we've got a limit. Oh boy. So x is approaching infinity. We have a polynomial on the top and a polynomial on the bottom. So when you have a polynomial on top and bottom, remember you're comparing degrees. Looks like if we FOILed this out, we would have a square on top and we'd have an x squared on the bottom. So we have to look at leading coefficients. So let's just look at what we would have on the top. We'd have a negative 2x squared plus some other stuff, but I don't care about it because I just want the leading term. And then on the bottom, we'd have just an x squared. Those cancel, negative 2. Horizontal asymptote at negative 2, both on the positive and negative infinity side. Quick, quick, quick. All right, next up, x is approaching 0. Ooh, 0 over 0 for sure, but I can factor out all kinds of fun stuff here. So that is, if we take out an x squared on the top, I'm left with 5x squared plus 8. And on the bottom, take out an x squared, I'm left with 3x squared minus 16. Those x squareds cancel. Now if I plug in 0, it's not scary anymore. I get 8 over negative 16, which is negative 1/2. So something I've been noticing a little bit is that some people have been doing a nice job of factoring out and canceling, but then they don't plug the value in. The whole point of canceling things out is that now when I plug in the value, it'll give me a real answer. That's the whole point. Cool. All right, f is a piecewise function defined here. Which of the following statements about f are true? Limit at 2, continuous at 2, differentiable at 2. Oh boy, all kinds of fun questions. So if it doesn't have a limit, then we got nothing. So I think that it probably is going to have to because, well, it wouldn't have to be continuous. Let's see. So limit at x equals 2. We got to check to see what happens from the left and right side. So what's going on here is this function is king except for at x equals 2. So let's see if we can factor that. That's x plus 2, x minus 2 over x minus 2. Okay, so we have a whole at x equals 2. Okay, because they cancel. And in fact, we can find the y-coordinate as well. It happens at 2, 4, because if you plug 2 in here, you get 4. So what's happening here is the whole time this function behaves like x plus 2. X plus 2. Except for at 2, where we have a whole. I can't erase just that little bit, so trust me if there's a hole there. And then it looks like our value at 2 is 1. Okay, I see what's going on now. So it definitely has a limit because we're approaching the same thing from both sides. That's true. It's not continuous because we're not plugging in the hole. The value is not 4. If it was 4, it would plug in the hole, you'd be done. So it's not continuous, which means it's not differentiable. So that means it's only 1. It has a limit, but it's not continuous, which means it's not differentiable because it's not continuous. This is the spaghetti thing, right? And you put a piece of spaghetti in there, it would wiggle around. You have nowhere to put it on the tangent line. All right, next up. Cosine of 3x. They want f prime of pi over 9. So let's do f prime of x first. That would be, so derivative of cosine is negative sine of 3x. Then chain rule, multiplied by the derivative of the baby, which is 3. So let's write that as negative 3 sine of 3x. So you'll notice that often with chain rule, they don't give you hard problems. They just give you problems that show that you know the rule. They just want to see if you know it. They don't want to see if you can do an impossible problem. So let's see if we can do this now. So let's evaluate that at x equals pi over 9. So let's plug it in. So we have negative 3 sine of 3 pi over 9. 3 pi over 9 is pi over 3. So it's negative sine of pi over 3. Pi over 3, right there. Sine is the long value, so this is negative 3 times root 3 over 2. And there it is, e. All right. Next up, Graph of f is shown above. Which could be the derivative of f? Looking for two zeros. So it's not this one, because that has 3. Not this one, because it doesn't have any. And not this one, because this 0 is at 0. And our zeros are like at a negative value and a positive value. We start with positive slopes. Then we go negative for a while. Then we end positive. So we should go positive slope, positive slope. So I'm looking for a derivative that has positive values, negative values, positive values. And you can see I'm pointing at B because that's the one that does it. We have positive here, then from here to here we're negative, and then we're positive at the end. This one does the opposite. This one doesn't have it in the right spots. Cool. All right, what are the horizontal asymptotes of this graph? This problem was the lowest average ever on a multiple choice problem. They threw it out because they realized that teachers were not teaching this accurately. So if you're looking for horizontal asymptotes, you got to send x to positive infinity and x to negative infinity. Now you might be saying, Mr. Fransky, I thought that those asymptotes were always the same. Only if they're polynomials on the top and bottom, but we have exponentials. Remember when we had those e to the x problems where there's e to the x on top and bottom, we said sometimes it's dominant, sometimes it's not? This is exactly what they're talking about. So let's look at negative infinity first, because that's easy. As x goes to negative infinity, 2 to the negative infinity is insignificant, right? Because 2 to the x looks something like this. So as x goes to negative infinity, these guys don't matter. So as x goes to negative infinity, we have an asymptote of y equals 5. As x goes to positive infinity, now these are very, very important. The 5 and the 1 won't do anything. So we have positive 2 to the x over negative 2 to the x, and those cancel out to be a negative 1. So y equals 5 and y equals negative 1 are the two that you're looking for. E. All right. Here comes one of those derivative definition problems. So tangent of 3 times x plus h minus tangent of 3x over h. I would not ever want you to try to find this limit. There's no reason to. In fact, it's hard. I don't know the tangent sum rule, but this is just the definition of derivative. F of x plus h minus f of x divided by h. For what function? What's the function that we're finding the derivative of? What's f of x? Always just look right here. Tangent of 3x. So what they're asking for here is the derivative of tangent of 3x. You don't have to do any more work. Now we can use the trick. So if you see this, don't do the limit. Use the trick. Just look at what your function is. So derivative of that is secant squared 3x multiplied by 3. 3 secant squared 3x. There it is. C is missing chain rule. A, I have no idea what's going on there. Probably if you plug in 0, you get 0 over 0. That's probably just trying to catch some people. D is thinking, I guess, that derivative of tangent is cotangent, but it's not, and it's definitely not non-existent. Cool. All right. Given a figure above here, f has domain 0 to 4. Which of the following statements is true? Limit as x approaches 2 from the left of f of x exists. Yes, it would be approaching that y value, whatever it is. Limit as x approaches 2 from the right exists. Yes, right? That's whatever this value is, whatever that flat value is right there. And limit as x approaches 2 exists. Nope, different values. So just 1 and 2. There we go. All right, this just looks like a power rule question. This is x, they're asking for the derivative of x to the negative 3 minus x to the negative 1 plus x squared. And they want to evaluate it at x equals negative 1. So the derivative there is to be negative 3 x to the negative 4 plus, because the negative comes to the front, x to the negative 2 plus 2x, evaluated at x equals negative 1. So plug in the negative 1, negative, so this is, let's rewrite this, negative 3 over x to the 4th plus 1 over x squared plus 2x. So plugging in a negative 1, can't read that anymore, let's rewrite it. Negative 1. All right, so plug negative 1 in, that's negative 3 over a positive 1, so it stays negative, plus 1, because 1 over positive 1 when you square it is 1, and then minus 2. 3 plus 1, negative 3 plus 1 is negative 2, minus 2 is negative 4b. Cool. Moving on. F of x is e to the x. Which of the following was f prime of e? Well, let's find f prime of x first. Derivative of e to the x. We actually haven't done that yet. Huh. Well, that doesn't matter because they're giving different definition of derivative. Duh. All right, we don't know how to do the derivative of e yet, but we can do it using exponent rules and definition of derivative. So remember, f prime of x is always the limit as, in fact, we're going to use f prime of a here because it's a specific value. Limit as h approaches 0, f of a plus h minus f of a divided by h. So we want to know f prime of e. So those a's are going to be replaced by e's. So e there and an e there. Here an e, there an e, everywhere an e. Old MacDonald, right? Yeah. Okay. So f of e plus h. So if we plug that into the function, that would be e to the e plus h minus f of e, which is e to the e divided by h. Limit as h approaches 0. So let's see if that's here. E to the e plus h minus e to the, I think it's e. Of course it's e, right? E's everywhere. Great. All right, next one. Ooh, quotient rule. So that's f prime of x. Low d high. Well, d high is just 1. Minus high d low. Secant squared x. Over the square of low we go. Tangent x squared. Thank goodness I chose pi over 4, right? Because tangent is 1 there. So tangent of pi over 4 is 1. We'll use that a few spots. And secant of pi over 4, that would be 1 over cosine of pi over 4. Cosine of pi over 4, that is root 2 over 2. So this is 1 over root 2 over 2. Multiplied by the reciprocal, it's 2 over root 2. Rationalize, root 2. Root 2's, that gives us 2 root 2 over 2, which is root 2. All right, so we've got our tangent value, we've got our secant value is root 2. So let's plug some things in. So tangent of 1 is 1, so we got 1 times 1, which is 1, minus x, which is pi over 4, times secant squared. So root 2 squared is 2, divided by the square of tangent, which is 1 squared. So we got 1 minus pi over 2. There we go. It's e. Easy peasy. Moving on. Which of the following functions shows that the statement if a function is continuous at 0, then is differentiable at 0 is false? So first of all, we know if you have a corner, right, that's continuous without being differentiable. Interesting. But we know that if it's differentiable, it must be continuous. So anyway, let's see what we can do here. So we're looking for a function that's continuous but is not differentiable. Continuous but not differentiable. Continuous but not differentiable. And it has to be at x equals 0. So some of these it might not be continuous. Let's see what's going on. So the first function, we got f of x is, that would be 1 over x to the 4 thirds. So this is definitely continuous at, oh, no, lies. It's not continuous at 0. Because at 0, this would have some kind of vertical asymptote, right? Because you have a number over 0. So that doesn't show us anything because it's not even continuous at 0. And b will have the same issue because we'll have an x in the bottom. So it's c, d, or e. Well, e is just the lane change, right? That is both continuous and differentiable at 0, so it can't be e. So we're looking for one of these two, c or d. Because x to the 1/3, that's the cube root of x. That one's fine, continuity-wise. And x to the 4 thirds, that's the cube root of x to the 4th. That also is fine at 0. You can cross over 0 without any issue there. So what we're going to do now is take the derivative of each and see which one is not differentiable. So the derivative of this guy is 1/3 x to the negative 2/3. And this guy would be 4 thirds x to the 1/3. So some warning bells should be ringing right now. Negative exponent with 0 is not going to work. 1 over 3x to the 2/3. Nope. So this one's continuous, but it's not differentiable at 0. So that's the one you're looking for. Really what you have to do is you have to find an exponent between 0 and 1. Because then it'll work for 0 when it's regular, but when you take the derivative, it'll reduce to below 0, and that's when you have that x in the denominator. Cool. I think these are our last two. Sine of x minus pi over 4 over x minus pi over 4. X is approaching pi over 4. That looks like sine 0 over 0. That should send off some warning flags, right? What's the limit as x approaches 0 of sine x over x? We've learned that one and talked about it a lot, right? It's 1. So I'm tempted to just say this is going to be 1. Let's see if it works out. You can do some substitution here. if you say u is x minus pi over 4, then this becomes limit as x approaches pi over 4 of sine of u over u. The trouble here, though, is that we have x over here and we have u here. So what we do is we say, well, as x approaches pi over 4, what happens to u? That just becomes u is turning into 0. U approaches 0. So indeed, we do have 1. That's all there is to it. All right, last one's another definition of derivative using limits. So let's see here. They're asking limit as h approaches 0 of this whole mess. This looks a lot like a derivative. What's our function? This is our a value, right? 1/2 is our a value. It looks like the function is 8x to the 8th power. And they want f prime of what? 1/2. So let's do that. F prime of x. Now we're just going to use the trick. Don't try to evaluate this limit. 8th power, yuck, that's going to be gross. Take forever. So that'd be 64x to the 7th. So we're going to evaluate that at x equals 1/2, which is 64 times 1/2 to the 7th. 2 to the 7th, ooh. 2 squared is 4, cubed is 8, to the 4th is 16, to the 5th is 32, to the 6th is 64, to the 7th is 128. So this is 64 over 128, which is 1/2. That's all she wrote. So hopefully you learned a little something watching my ramblings here on the multiple choice. I love you guys. That's why I'm here. Have an excellent day.